Lesson 34, properties of parallelograms. The main concept that we have on the finding the area is base times height. That holds true for all parallelograms, so keep that in mind. Properties of parallelograms is basically a list of things that all parallelograms share. So if you go to page 218 in your book, there's a nice, beautiful little chart that's there that you can either copy or write down a page number for or something so that you can refer back to it. But I'm going to give you some of these quick and dry, okay? First rule, not really rule, first property of parallelograms is they have opposite parallel sides, okay? That's what these little lines mean, okay? So I'm going to zoom in just a little bit more and get a little bit closer. See if I can get that to tune out. Okay, is that clear? You guys all right with that? Can you see all the letters? J, K, L, M? Anybody not able to? Oh, there it goes. Alright, here we go. So, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So look at opposite angles. M and K are opposite angles. They are on opposite sides of the parallelogram. They are congruent to each other. Okay? All parallelograms hold that property. Look at J and L. Those are also congruent. They're again opposite angles. Okay? Looking at number 2, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, meaning B and S, when added together, will be 180. S and T, when added together, will be 180. T and U, when added together, will be 180. U and V, when added together, will be 180. This only works in parallelograms. Okay? So, at any point, if you get a question that talks about consecutive angles, that just means in order. S to T, or T to U, or U to V. I can't say V and T equal 180. They're opposites. They're not consecutive. Okay? If a quadrilateral is a parallelogram, then the opposite sides are congruent, just meaning that DA is congruent to CB. Also, AB is congruent to DC. We already kind of knew that. Opposite sides are congruent. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Now this is one that's a little more difficult to understand, so I'm going to try to draw it out for you. QE, now keep in mind that from here to here is a diagonal. Opposite corners, vertexes, are connecting. So these two diagonals intersect at point E. Basically, that creates a midpoint. They bisect each other. So QE is equal to EO. Also, PE is equal to EN. Okay? They're separate lines that are not equal to each other, like NE is not equal to EO. But along this diagonal, where the midpoint hits, it shows you that they're equal to each other. Any questions on any of those drawings? Okay, so we're moving on then. Whew. I'm going to go over example 1, and we're not going to write it down because I feel like you're not going to pay attention if we wrote it down at the same time as we talked about it. So here we go. Given WXYZ is a parallelogram. So, because we know that, we know all of the things that are listed in the properties. So we know that Z and X are congruent. We know that WY are congruent. We also know that side ZY is congruent to side WX. We also know that ZW is congruent to YX. Okay, I'm just going through the list of properties here. I know that angle Z plus angle W is equal to 180 degrees. Same thing for W and X. Same thing for X and Y. Same thing for Y and Z. They always equal 180 when adding consecutive angles. If I were to draw the diagonals of this parallelogram and label the point where they all meet M, then XM and MZ are equal to each other. Also, YM and MW are congruent to each other. Okay? So that was just a review of the properties that we just went over. Let's go into what they actually give us. Just that it's a parallelogram. So we're going to use definition of parallelogram a lot here, I'm sure. Notice that they drew these arrows. These mean that if it has one line made for the arrows, then it's parallel to this one line made for the arrows. This one has two lines made with arrows, so that means that these two sides are parallel. Okay? So first they start out by listing the given, just like we always do. Next, we state the obvious, because they put it in the picture, we better write it down. So they said WX and ZY are parallel. Then it said WZ and XY are parallel. We know that because of the definitions of parallelograms. I'm going to try to keep that picture on there. Okay. Next, we talk about angle W and angle X being equal to 180 because they are consecutive. They go in order. So they use same-side interior angles. Notice the definition of consecutive angles is the same as that definition here. Consecutive angles are supplementary. Consecutive angles are supplementary. So same-side interior angles is a consecutive angle. You might make that note. Same thing for angle X and angle Y. When added together, they equal 180 degrees. Because they both equal 180, we can set them equal to each other. So they took angle X and Y and set it equal to angle W and X added together. And we can do that because substitution property of equality. Because they're both equal to 180, we can set them equal to each other. Next, I can start to solve. I can get rid of the thing that they have in common. They both have X in them. Since they both have X in them, I subtract the measure of angle X out. So subtraction property of equality allows me to do that. I'm now getting rid of the measure of angle X on both of those. For the next piece, I have the measure of angle Y and the measure of angle W isolated. So I know that Y and W are congruent to each other. So I'm going to draw that in on my picture. I draw those little arc marks. Okay. Looking at number 7, they start talking about the next two consecutive angles. Because I've already proven the first part that they wanted me to prove, that W and Y are congruent to each other. So I'm going to move on to the next pieces. Angle Z and angle Y, Z and Y, equal 180. Also, X and Y equal 180. So I can set them equal to each other. Again, that's substitution property of equality. It allows me to do that. Subtract out the things that are in common. I have a Y in common here, so I subtract Y, gets rid of it, gets rid of it. I'm left with angle Z and angle X being equal to each other. This is just familiarization with proofing, basically, is all it is. Questions? There's got to be some. Okay. Another way to look at flowcharts. Proofing. These are really long and intense on this one. So this one's proving consecutive angle parallelograms are supplementary. We're proving that. So it's just showing that Y and Z are 180 degrees. Z and Y are 180 degrees. We can refer back to this if we need some help with flowchart proofs. Okay? We're not going to go through it right now. You can look back at it on your own. On example 3, it gives us a paragraph proof. Okay? It basically writes down everything that we put in a 2-column proof, but writes it in paragraph form. Okay? So WXY is a parallelogram. So, and then it goes on and go on and goes on and go on. I always write everything in 2-column proofs and then convert them to flowchart proofs or paragraph proofs. It's really hard to just start writing this. You've got to do a rough draft, basically. So your statements and reasons column will be your rough draft for all of this. Okay, so let's go back to the one that we actually did in example 1. And I will say this as if it were a paragraph proof. Okay? So, we would start with this. WXY is a parallelogram from the given information. Sides WX and ZY are parallel. Also, sides WZ and XY are parallel from the definition of parallelograms. The measure of angle W and the measure of angle X is equal to 180 degrees. Also, the measure of angle Z and the measure of angle Y added together is 180 degrees. This comes from the same side interior angles are supplementary, the definition of same side interior angles, the postulate, whatever you want to use to name that. Okay? And it continues on the same way. We're just putting it in common mathematical language. I wouldn't say common language, period, but common mathematical language. All the way through. All right. So aside from the proofing stuff, we're going to move on to example 4. So get there if you're not already. Yes. Example 4 is more mathematical than the rest. So example 4, finding unknown measures of parallelograms based off of our knowledge of what parallelograms offer us. We need to find measure of angle x. So when I zoom in on this, I want to look at my x's specifically. Notice that my x's are here and here. What do I know about side PQ and SR? They're congruent to each other. In other words, they're equal, right? So I can set them equal to each other. So I'll do that to find out the value of x. Okay, when I look at part B, it says find the value of y. Look at the y's. It's PT and TR. What do I know about that diagonal when they cross at T? They're equal to each other. They bisect, right? They set them equal. So when I solve that one, I'm going to set those two equal to each other. So on example 4, part A, I decided that I'm going to set those two equations equal to each other. So 3x plus 10 equals 7x minus 8. And on part B, we decided that 1/2 y plus 10 is going to be equal to 2y minus 2, right? So we start in. I subtract 10 from both sides. Why should I not subtract 10? Why should I add 8? Because I'll end up with a negative, so it's better that I add 8 first. So here we go. I'm going to add 8 instead of subtract 10. I have 7x left, equaling 18 on this side, and 3x. Now what? Subtract 3x from both sides. I get 18 being equal to 7 minus 3 is 4x. Now what? Divide both sides by 4, and I can either write down what I get as a decimal or leave that in fractional form as 9/2 or 4.5, whatever you want to do. 4.5 is probably the way most of you will write it, so I will do that. 9/2 is the same. Okay, so that's part A. Part B, solving it the same kind of concept. I need to add 2 to both sides. I'm left with 2y over here, 12 right there. Should I convert my 1/2 y to 0.5? Would that help? Okay, I will do that. So 0.5y. Now what? What do I do?
Oh, sorry, I'm hungry.
Way ahead. I subtract 0.5. So those go away. I get 12 equaling 1.5y. I divide to isolate my y. So y then equals 12 divided by 1.5, which is, say that again? 8. Thank you. And there is my answer for the 2. Now if it asks us to find the length of that, I would simply take this and plug it back in. I would take this and plug it back in. So if it said find the actual length, I would take 4.5, I'd plug it in and solve. Okay? It didn't in this case, so I'm not going to. Example 5, they use an example from farming, which I don't think is 100% accurate, but it might be. Who knows how they make roads in Kansas? In Kansas, the highway department builds gravel roads to evenly divide parcels of land. If a farmer has a plot of land shaped like a parallelogram with a diagonal of 1 mile, as shown, to calculate the values, it asks us to calculate the values of x and y to the nearest hundredth. So again, we're looking here. This is supposed to be a parallelogram that represents some parcel of land for a farmer in Kansas. The diagonal is 1 mile. It also shows us that this diagonal creates a right triangle in this particular instance. So we should automatically think probably going to use Pythagorean theorem at some point. I think if a farmer in Kansas had a parallelogram shaped piece of land, he might want to reconsider what he bought. So he might want to learn the Pythagorean theorem, huh? All right. So we're going to find our x first. If we're going to find x, we're going to use this triangle. So I'm going to redraw that triangle so we can look at it, and then we're going to have to solve some stuff for it. So this triangle, when you pull it out of that parallelogram, is just a right triangle all in itself. Okay? So this leg was 1 mile, the other leg was x, and the hypotenuse was 2x. Yeah, I sure can. Okay, from here, I can start Pythagorean theorem. So my first leg will be 1, so 1 squared, plus my second leg, which is x, so x squared, and my last leg, which is 2x squared. Sorry, not my last leg. My hypotenuse is 2x squared. So I need to solve each piece of this that I know how to do. So 1 times 1 is 1 plus x squared. I can't do anything to that. I'm going to go ahead and give this squared to each of those. So I get 4x squared. Now, I have to do what? Can't do that yet. I have the same last name. So I need to do what? I heard somebody say subtract and somebody said cancel. I'm going to go with the subtract. So I subtract x squared. So I have 1x squared and 4x squared, so I'm left with 3x squareds, right? Equals 1. Now how do I get x squared by itself? How do I get rid of the 3? Divide by 3. So I divide by 3 on each side, right? So now I have x squared equals 1/3. Now how do I get rid of the squared? Square root. This is a crazy problem. So I take 1/3, I square root it, and I get some really tiny answer, I'm sure of it. Say it again.
0.5773.
Let's round it to the nearest hundredths. 0.58. Right? Okay. I'll round it to the nearest hundredth, 0.58. It's kind of weird how the number got bigger when we square rooted it, huh? Anyways, that is the answer for what x is. That would be 0.58 of a mile, by the way, so it's not really that small of a number. So 0.58 of a mile. So basically half a mile is what it is. Next I'm going to solve for y. Looking back at what y represents, it is the angles of that parallelogram. So when I look at my y's, if I can get this thing to focus a little bit better than it currently is. Okay? When I look at my y's, I notice that this one and this one are going to be what? Again, ignore, it's not the whole angle, otherwise you're on the right track. Remember, we're just looking at this right triangle. So there's a 90-degree angle here. What do I know about all 3 angles of equals 180? Right? But in a right triangle, the 2 other angles equal what? 90, obviously. We already used 90 of it, there's only 90 left. So I'm just going to write that down. Yay. So 3y minus 1 plus 9y plus 2 equals only 90. Combine like terms, I get 12y plus 1 equals 90. I have minus 1, 89 on that side, and I'm left with 12y. I divide by 12.
7.4166.
So I get 7.42 approximately.
Is that a mile or?
No, that's just an angle. It's part that creates the angle. The only reason I wrote mile here is to put that into perspective for you on that other side length. You actually don't even need a label on there because it's not asking for the dimensions. Okie dokie.